All right, we're going to go into the multiple choice for our review. So here we have this first problem. And I see that it has comparing to 23%. So that was the claim. And then they give us one sample to compare to that claim. So when we did this by hand, we took that one sample result, 15 divided by 84 was 0.18, and we minus the mean over the standard deviation. And remember, the formula for that standard deviation was true p times 1 minus p over n square root. Okay, that one right over here. Okay, so we use true p. That's the best it can be. All right, and then once we got that z-score, then we went more extreme to get the p-value. So I norm CDF, since this was a negative 1.09, I norm CDF the bottom area because they were, let's see here, does it reduce the mortality rate? So that was another reason why I went lower. So my p-value was 0.1379. So this is not evidence because the p-value is not low. It is greater than 0.10. Now, not to necessarily encourage you to do this, but for multiple choices, you can do this. There are some things, some problems, and you'll see this through the review, and it will happen on the test, that knowing how to do all of this stuff by hand is necessary to be able to do the problem. And I guarantee you, College Board has put problems so that it confirms that you still maintain the way to do these problems by hand. But you could have technically gone and done a one proportion z test in your calculator. And then you would put in there, so where this looks is down here, number 5, a one proportion z test. And you put your null hypothesis for the p naught, and then you would do your numbers here. I think what was it, 15 out of 84. And then it was wondering if it has gotten less than the null hypothesis. It's gone lower than, and then there you go. So it has a little bit different, negative 1.12. The p-value is 0.1313, which is a little different than what I got, but the decisions are the same. Now see, look here. This does have the correct p-value, 0.1314, close, but the answer is not yes. So see, that would have also been another trigger that you might recognize, ooh, that's the right p-value, but then if you don't know, they'll get you there because it's supposed to be no, not yes. All right, so here we go. Number 3, which of the following are true? None of them are true. So a p-value that's smaller than 10% is not necessarily smaller than 5%. And to be significant, you're smaller than alpha. You're farther away from the null hypothesis than the rejection in the rejection region. So you wouldn't decide the type of tail after the data is gathered. You do that before based on what you are inquiring and what you are investigating. And then here, the hypothesis test conducted at the 1% test does not mean that there's a 1% chance of rejecting the null. Now, yes, that would be the case if the null is true. But if the null is not true, then all of this yellow area is the probability of rejecting the null. And you don't know how much that is. That's called power. Okay? So, number 3 is true if the null is true, but it's not necessarily. So there we go. All right, so here's one of those ones where you have to be able to solve for the sample size. So the key is this here, setting this up, because you know that when you have your this right here, you know that this section behind the plus and the minus is the margin of error. So here's the margin of error that makes the whisker on a confidence interval. So we have a proportion problem here. So we're going to set our margin of error equal to this z star times the standard error for proportions. All right, so then we have to be 94% confident. And remember that if we are 94% confident, then that's 94% in the middle. So if we have 94% in the middle, then that's going to put 3% in one of the tails. And so we've got inverse norm, because this is a proportion problem, because they're talking about the percentages of New York marriages that end in divorce in the first year. And so here's the margin of error they're interested in. Here's the critical value of how confident they want to be. And then here is the standard deviation, or the standard error. But we do not know a claimed p-hat, or we did not get a sample result to base our answer, our standard error on. So we have to use 0.5. Remember that the best it can be is if you use true p. If you don't have that, you can just use p-hat. The worst case scenario is those don't jive. Please don't cry. Just use 0.5. So we do. And I kept all of that in my calculator, and I got 180.33. So that was the next biggest that I could have. So the smallest possible of these choices was 181 would work, because 180.33 is the minimum, meaning 181. Based on this estimate and the margin of error, which of the following is the appropriate conclusion? So here we have that, we had our 26, which is the sample results, okay? And then we did a margin of error of 1.5. So in essence, I can see it going from 24.5 to 27.5. But that doesn't mean that the age of every first-time mother in the sample is that. That just means it's plausible. There's lots of different things it means. But none of those first four answer choices are what it means. But because of this, it is plausible that the average age, because we're trying to get an estimate for the true average, so it is plausible that the true average could be 27, because I'm 95% confident that the true average age of first-time mothers is between 24 and a half and 27. And so that could be 27 and a half, and that could be 27. All right, number 6. So this was one where you were identifying the calculator. Copied this from the formula chart. So this, you just knew what was the sample P1 and the sample P2, and of course the sample size for 1 and 2, and you filled everything in appropriately. And there they were, is B. All right, here we go. So here they're saying that they made a following conclusion to reject the null hypothesis. So which error could have been committed? So think about it this way. You rejected the null. So when would rejecting the null hypothesis be an error? Okay, let's see. If the null is really true, but you get a sample that causes you to reject the null, that's a type 1 error. So if the null is really true, but you get a sample, so when could an error, they rejected the null. Rejecting the null being an error means HO is true, but we rejected it. That's the definition of a type 1 error. So A is the case, because B says they conclude more than 50% want the earlier lunch when more than 50% do, and that's not an error. All right, so we're just going to go ahead and stop right there through doing numbers 2 through 7, and then we'll move on to the next.